Okay, good morning, students. In class, we have discussed regarding the model 3 question. The three questions we have discussed: capacitors connected in series, capacitors connected in parallel, and basics of capacitors and reactive power of capacitors. Today we shall discuss regarding the that is fourth question. Explain the control of open circuit voltage with the shunt reactors. This is the Model 3 question. This is control of open circuit voltage with the shunt reactor. Shunt compensation with reactor. What it will happen when we use a shunt compensation with reactors? It increases the virtual surge impedance. What it will happen means the shunt compensation with the reactors, if we use, it will increase the virtual surge impedance and it reduces the virtual natural load. It increases the virtual surge impedance and it reduces the virtual natural load. This for this particular at that which we can apply, we can achieve the flat voltage profile. Okay, if we use a shunt compensation with reactors, then the load at which voltage profile will be achieved, flat voltage profile we can achieve. So here, that is what they are saying. Shunt compensation with reactors increases the virtual surge impedance and reduces the virtual natural load. That is the load at which a flat voltage profile is achieved. With the Ksh is equal to 1, that is Ksh is equal to 1 shunt compensation factor, the voltage profile will be flat at no load or open circuit. When for open circuit or no load condition, the voltage profile will be flat if we use a shunt compensation with reactors. In practical, shunt compensating reactors cannot be uniformly distributed. If you use a shunt compensating reactors, that is we cannot achieve a uniform distribution in the system. Instead they are connected at the end of the line, intermediate points, usually at intermediate switching substation. You can see this figure, you'll understand this is the power system circuit, or we can say the line, transmission line or distribution transmission line. Intermediate switching station. This is a power system. This is the generation part and this is the transmission side. And here also generators, transformers, circuit breakers, and we are using a shunt reactors. They are saying that instead they are connected at the end of the line and at the intermediate points, usually at the intermediate switching substations. Arrangement of shunt reactor on a long distance high voltage AC transmission line. On a long radial line, the switching stations may occur typically at intervals between 50 and 250. For long transmission line, for longer radial line, the switching stations may, the distance between that is, it may between 52 and 250 miles. Okay, between 50 and 250 miles, we need to connect the shunt reactors. In the case of very long lines, at least some of the shunt reactors are for long lines. Okay, now for 250 miles, we will connect somewhat between distance 50 miles. For 50 miles or 250 miles, we will consider and make some lists and we will connect the shunt reactors. But for a long, more than 250 miles, or it is a long transmission line, at least some of the shunt reactors should be connected permanently, okay, to the line. In order to what, why we should connect permanently? Because to give a maximum security against over voltages in the event of a sudden rejection of load or open circuiting of the line. In the case of very long lines, at least some of the shunt reactors should be connected permanently. Okay. One thing you need to remember in this is shunt compensation with the reactors. If you use it, it will increase the natural loading and it will virtual natural loading and it will decrease the, but it will increase the surge impedance and it will reduce the, okay. can be used at the intermediate stations, and shunt reactors will not uniformly distributed. Okay, shunt compensating reactors cannot be uniformly distributed. These 3 points you remember. And if we use a shunt compensation with reactors, we can achieve a flat voltage profile. And for shorter lines, we can use as a intermediate. Okay, intermediate we can use switching in, that is we can connect and we can disconnect the shunt reactors according to the requirement. But for long lines, some, at least some of the shunt reactors should be connected permanently for long lines, because for long lines, in order to maintain that is maximum security. Okay, in order to maintain the without losses, the transmission lines should not occur any losses. Okay, in order to maintain security purpose, and also in order to give a maximum security against over voltage in the any event of sudden rejection of load or open circuiting of the lines. Because of that only, we need to connect the some shunt reactors permanently. On shorter lines, on a section of a line between unswitched reactors, the overvoltage problem is less severe. For shorter lines, it will be less severe. So, in that cases, the reactor line between unswitched reactors, the overvoltage problem is less severe, and the reactors may be switched frequently to assist in the hour by hour. If it required, then we can connect. If does not require, then we can disconnect. We can act. It acts as a switching. Okay, for shorter lines and medium. For longer lines, some should be connected, some should be it should switching. Okay. Shunt capacitors are usually switched. If there is a sudden load rejection or open circuiting of the line, it may be necessary to disconnect them very quickly to prevent them from increasing the voltage still further. In the case of any load rejection or open circuit, we first what we very quickly, because it will increase the voltage level. Okay, it will increase the voltage still further, and also to reduce the likelihood of ferro resonance where transformer remains closed. This is regarding the control. This is regarding the control of open circuit voltage with shunt reactors. Okay, one thing, shunt compensation with reactors, if you use, it increases the virtual surge impedance and reduces the virtual natural load, which can be achieved flat voltage profile. And shunt compensating reactors cannot be uniformly distributed, and it can be acts as a switching device. Okay, we can, whenever we want, we can connect. That is, we can use as a switching. Okay, and we can, some should be connected permanently for long transmission lines. For longer lines, some, at least some should be connected permanently. But for shorter lines, we can manage by whenever we require, we can connect. Whenever we don't require, we can disconnect that one. In order to maintain a voltage, okay, in order to maintain voltage, or in case of any load rejection or open circuit, it should not overflow or over voltage. In order to maintain only the shunt reactor, some should be connected permanently. And what we can say here, this circuit you need to write. If they ask for 10 marks, for 6 marks, just write down 4 points and write down the circuit. Okay. In next class, we shall discuss with the other questions.